Good morning, students. So now in today's class, we have to discuss with that sequence pattern discovery. So before discussing about the sequence pattern discovery, so far we have to discuss the how to handling the categorical attributes. In the categorical attributes, how we can offer in categorical attributes, how to binarizing the categorical and symmetric binary attributes, and how to handle the continuous attributes. So in the how to and whenever you have to handling the continuous attributes, you have to use the three types of methods. Those are the discretization based methods, statistics based methods, and non-discretization methods. Non-discretization methods. So non-discretization is simply called as mini a priori. So these are the three methods you have to use whenever you have to handling the continuous attributes. So these are the concepts so far in previous classes we have discussed, and now and also we can discuss with that how to handle the concept discovery. In the concept of discovery, so far in last class we have to discuss from the ancestor to descendant. The concept hierarchy is the multi-level organization of the various entities or concepts defined by the particular domain. Simply we call it as concept hierarchy. Generally, this concept hierarchy is represented with the directed acyclic graph. Generally, you have to call it as DAG, directed acyclic graph. So, by with the graph parent child, you have to represent it from ancestor to descendant. So these are the what are the advantages you have. These all things we have to discuss in last class. And it's a time sequence. Whenever you have to take the sequence database, uh, and in sequence databases, what is the timestamps you have that you have to represent it uh, in sequence databases. So these all things we have to discuss it in last class. Now in today class we have to discuss with that sequential patterns. How we can define the sequential patterns. In the sequential patterns, mainly we have to discuss with that market basket data often contains temporal information about when an item was purchased by the customers. Such information can be used to the piece together the signs of the transactions made by the customer over a certain period of time. So generally, it is represented with the event-based data collected from the scientific experiments and monitoring the physical streams such as telecommunication networks. So mainly here we can use the sequential patterns uh, and what are the algorithms you have to use. These all things you have to discuss here. And the input to the problem of the discovering sequential pattern is a sequence data set, which is we have to represent it in each row records the occurrences of events associated with the particular object at a given time. For example, the first row contains the set of events occurring at the timestamp t equal to 10 for object. By sorting all the events associated with the object A, it is increasing the order their timestamp. A sequence of object A is contained. What are the in the timestamp you have the what are the events will be occurred. That events you have to represent it with the timestamp. Generally, we have to represent the sequence of web pages to the particular website visitor. How we can represent it here? See here, this is the examples of the sequence of differential transactions by the customer at online store. Digital camera, iPad, memory card, headphones, iPad cover. So this is the sequence of different transactions by the customer at the online store. Sequence of initial events and causing the nuclear accident in 3 Mile Island. So here, what are the sequence steps event is occurred while accident will be occurred. So this is the step. These are the examples of the sequence, and in the sequence pattern discovery, mainly you have to discuss. This is the sequence data. You have to represent it here. The customer and the sequence and what is the transaction we have to perform, what is the event we have to perform. So see here in this diagram it shows element transaction. So sequence and element transaction. E1, E2 is the events, and E1, E3 is the another event. E2 is the another event. E2 and E3, E4 is the event. So in a particular transaction, at the at the particular timestamp, we have to represent it that particular transaction. So, for example, you have to whenever you have to went to the supermarkets. So first you have to billing your what are the items you have to purchase. That is in a particular time. That particular time you have to specify the your transaction. So similar way in next transaction in another time. So like this way you have to represent it. First customer is purchased by two items, that is E1 and E2, and second item, second transaction, second customer you have to purchase the E1 and E3. So that is a particular timestamp you have to represent it like this: E1 E2, E1 E3, E2 E2, E3 E4, like this. Timestamp also you have to represent. That is the sequence data. Generally, in the sequence databases, you have to here you have to consider customer sequence database, uh, sequence, purchase history of the given customer, a set of items brought by the customer at a time t, and generally what are the events will be occurred in that customer, and the purchase history of a given customer, uh, books, dairy products, CDs, so on. So whatever the events, the daily events we have to purchase, that is simply called it as items. So total items you have to purchase, that is simply called it as transaction, that is element. And what are the procedure we have to consider, that is the sequence, purchase history. First you have to consider one first element you have to pick, and second item, third item. Like this way we have to purchase the 10 items. 10 items we have to pick picking that that is the purchasing history. So that is related to the sequence database for related to the customer, and a similar way web data. So web data sequence you have to represent the browsing activity of a particular web visitor. The collection of files viewed by the web visitor after a single mouse click. The collection of files viewed by the web visitor after a single mouse click. That is simply can represent it as transaction. And what are the items you have to purchase? That is generally in the web related uh, home page, index page, contact information. That is the events. For example, whenever you want to register into one website like Google, so you have to enter all the data then home page, and you want to purchase something, you have to consider on that, and you want to see the contact information. That time you have to consider the contact page. So these all pages you have to represent it with the submit one single you want to purchase click. So the collection of files viewed by the web visitor after a single mouse click. So you want to purchase the items, or you want to purchase, or you want to generally you have to see here. That is the you want to save the data. That means related to the customers or home page. So just you have to submit the button. So whenever you have to click on the submit button, automatically the data you have to store. That is related to the web data sequence database. Similar way, event data. History of the events generated by the sensor, events triggered. Events triggered by the sensor at a time t. That is simply call it as event data. Uh, Similar way, what are the events items? You have types of alarms. You have to generated by the sensors, and the similar way genome sequences, DNA sequence of the particular species. That is the sequence of the people, and a similar way, an element of DNA sequence and basis of ATGC. So these all things you have to represent it here related to the sequence databases. That is the example of elements and events in the sequence data sets. Uh, See here, that is the sequence data, how it this is the timestamp you have to represent it, A, B, C. I have to consider, and it's the timestamps and what are the events, what are the transactions you have to purchase. These are the timestamps of the particular transaction. That is the sequence ID A, B, C. So A is a sequence ID is we have to purchase it at the timestamp is 10. Uh, then 20 the timestamp 20 and timestamp 23 they have to purchase the items 2, 3, 5 and 6, 1 and 1. And similar way in the B sequence ID they have to purchase the item. So we can represent it various dates, timestamps, and we have to consider as dates and times. So here you want to consider the dates. A is the person, that is the customer. They have to purchase it in the 10th date and 20th date, 23rd date. What the items they have to purchase. So that is you have to represent it with the timestamp. So that timestamps you have to represent it here. Next one, sequence data versus market basket data. So how it consider that is the date you have to consider here for the sequence database A, B, C, that is the customers, and the data is date you have to consider as 10, 20, 23, and they have to purchase customer A in dates, 3 dates they have to purchase, and items brought. So that is a 2, 3, 5 is the 1 day in 10th day. 1, 6 is purchased by at 20th date, and 1 is purchased at the 23rd date. So B, C, B is the person, they have to purchase 4 times on 11th, 17, 21, 28. See here, that is the items brought on different dates. That is the 11, 17, 21, 28 dates. In 4 days, they have to purchase the item. 4, 5, 6 on 11th. 2 is the item you have to purchase on 17th. 1, 2, 7, 8 items are purchased in 21st, and 1, 6 items they have to purchase on 28th. Similar way on customer C, they have to purchase the items on 14th, that is the 178. So that you have to only consider the events only in the market basket analysis. And in the market basket data, which is only you have to consider, that is items that you have to represent it as 2, 3, 5 and 1, 2, 1, 2. Most of the people they have to purchase 1, 2 only. That is the 7, 8 also. You can represent it in market basket analysis. See here, what is the formal definition of the sequence? Sequence means generally you know that that is a sequence of an ordered list of elements. So like sequence S equal to is a subset of A1, A2, A3, A4 like this. Here you have to consider the E1, E2, E3, E4 up to En. So each element is contains a collection of events, items, that is the E of I equal to I1, I1, I2, I2 up to Ik. That is the collection of events you have to represent. For example, you have to consider the transaction customer A, total S equal to customer A, B, C, D like this. And each customer you have to related information for that A1 that is the customer A equal to. So what are the transactions they have to purchase? That is each element contains the collection of events or items. Anyway, you have to call. Length of the sequence is is given by the number of elements is the sequence. A K sequence is the sequence that contains the K items. That is the AB, A has the length of B2 and its three sequences. See here the formal sequence A1, A2 up to AN is contained in another sequence S equal to B1, B2, B3. So here you have to take the two sequences. One is the T sequence and the second one is the S sequence. And both here M values always greater than the N values. So always S sequence values are greater than the T sequence values. That is M is always greater than the N. If there exist integers, I1 is less than I2 and less than up to I3 and so on up to IN, less than IN, such that A1 is a subset of B2 and A2 is a subset of B3. A3 is a subset or equal to B5. So you have to represent this data sequence, that is the 2, 4, 3, 5, 6, 8. That is the data sequence we have to represent. What is the subsequence here? We have to consider as 28 is the subsequence. Is contained S. So 28 elements are there in the data sequence. So it contains S. For example, 1, 2, 3, 4. That is the another data sequence. So in that, 1 is this individual element and 2 is an individual element. It contains. So no. So here 1, 2 is always in one set only. So that you have to represent it. But here we can represent the two individual subsets, two individual sets. That is the one is the one set and two is the another set. So it contains no. And similar way, 2, 4, 2, 4, 2, 5. That is the data sequences you have to represent it. 2, 4. So it contains S. Why? Because how we can say that it is the 2 is the one list and 2, 4 is the also another list. We have to 2 is the consider as first list and 4 is considered as the second list. So you have to consider as it contains S. And a similar way, 2, 4, 2, 5, 4, 5. 2, 4, 2, 5, 2, 4, 5. We have to represent. It contains S or no. That is simply you can say that three individual elements we have to consider 2, 4, 5. So here we have the 2, 4, 5. So in the first list we have the 2, 4, but whereas in the second list we don't have the 4. So here the 4 item we don't want to consider here in the second list. So it contains no. That is the way you have to say that. And next one is the 2, 5, 5. See is a subsequence 2, 5, 5. So here you have to consider 2, 4, 2, 5, 4, 5. So 2 is there in the first sequence, first list, and 5 is also you have there in second list, and 5 is also there in second list. If there, so it is a contain S. And a similar way you have to consider the 2, 4, 2, 5, 4, 5. So in that data sequence, you have the subsequence 2, 4, 5. 2, 4, 5, you don't have the 2, 4, 5 is a list. No. Only you have the 2, 4 or 2, 5 or 4, 5. But it is not, it is three elements not in a single list. So that's why you can say that it is no. So that's why you have to, it's contain S or no, you have to represent it with that formal subsequences of a sequence. Sequence pattern mining, generally you have to represent it here. The support of the subsequence W is defined as the fraction of the data sequences that contain W. So simply a sequential pattern is a frequent subsequence as a subsequence whose support is greater than or equal to minimum support. Given a database subsequent sequences, the user specified the minimum support threshold. Minimum support task find all subsequences with the support of greater than or equal to minimum support. So that you have to represent it as sequential pattern mining. Along with the example here, it shows what is the timestamps of various objects and what are the events performed in the timestamp, and what is the minimum supports that you have to represent it here. Minimum support 1, 2 is the what is the support? Minimum support is 50% to consider. Examples of the frequent subsequences we have to represent it here. So here you have the sequential patterns derived from the data set that contains the 5 data sequences we want to consider here. A, B, C, D, E. So here you have the object. So A is purchased on various timestamp 1, 2, 3. In first time, timestamp they have purchased the events or purchased the items 1 to 4, and second timestamp they have to purchase the 2, 3, and the third timestamp they have to purchase the item 5. Similar way, B is the person object we have to purchase it various timestamp in 1 and 2. In one timestamp they have to purchase the items 1, 2, and the second timestamp they have to purchase the item 2, 3. So like this way, you have the different customers they have to purchase it in the different timestamps. Now you have to consider, and minimum support is taken as a 50%. Suppose the people they have to minimum purchase is 50%. Uh, the example of the frequent subsequences, I want to represent it as 1, 2 is the how many people they have to purchase. Here 1, 2 is the people they have to purchase. A is the purchase 1, 2, and B is also purchase 1, 2. C is also we have to purchase 1, 2. D is not events are not occurred in a D as well as in a E also. Only 3 people they have to purchase 1, 2 out of 5. That is the 60%. So 60% of the support we have perform 1, 2. Next one, total 5 is total 5 we have the 3 by 5. So we get the percentage 50% you have to get. Similar way 2, 3. 2, 3 is purchased A as well as B is also purchased the 2, 3. C is also purchased the 2, 3. D is not purchased the 2, 3, and E is also not purchased. That is the 60%. Next one is the 2, 4. 2, 4 is purchased in timestamp 1, and a similar way 2, 4 is purchased in timestamp 1 of B, 2 of B, and a similar way 2, 4 purchased in the timestamp of 2, 4 at the C, and uh, 2, 4 is not purchased at the any timestamp in of the T, and E is purchased time 2, 4 is purchased in a timestamp 2 at the by the object E. So totally 4 times they have to purchase 2, 4 items. So 4 by 8, the 4 by 5 that is represented as 80%. So like this way, you have to calculate the minimum supports for the frequent subsequences 1, 2, 2, 3, 2, 4, 3, 5, 1, 2, 2, 2, 1, 2, 3, 2, 2, 3, 1, 2, 2, 3. So like this way, you have to you have to uh, uh, sequential patterns derived from the data set that contains the 5 data sequences. sequence data market basket. How we can find out the confidence uh, support and confidence? You have to find out with the 2 and 1. So now you have to consider. So what are the events you have to provide it? That is the 235 and 161, 256, 21278, 16178. These are the events you have represented. You can find out the formula for the confidence. That is the 2A1. That is the row of 2 and row of 1. Confidence to 1, 2 to 1. We have represented row of 2, 1 divided by row of 2. So you can find out the value. You can similar way. You want to find out the sequence for the 1, 8 and 7 with the confidence. You have to find out that is the row of 178 and similar way 1, 8. So that is the way you have to calculate the values. Calculate the confidence by using the formula. And how to extracting the sequential patterns. So here we have the n elements, I1, I2, I3, I4 up to In, and a candidate one subsequences from the I1, I2, and I3 up to In. That is the candidate one subsequences, and a candidate two subsequences with the I1, I2, and I1, I3, I1, I4. Like this way, you have to present the subsequences. Similar way, IN to IN, that is the candidate two subsequences. Similar way, I3, candidate three subsequences we have to represent it with the extracting the sequential patterns. Extracting the sequential patterns. So now we have to see here extracting the sequential patterns. A simple example. It shows that given two events like A, B, and B. In the A and B, we have to represent it 0 and A comma B. First sequence, the subsequence we have to represent it as A and B. This is regarding to the extracting the sequential patterns, and it's a simple examples we have to discuss it here. And the next class we'll discuss the generalized sequence pattern. Sequence pattern, how it represented with the candidate generation, candidate pruning, and candidate counting, support counting, and candidate elimination. What are the steps you have to follow? We will continue next class. And only few people are submitted the assignments. Remaining people, please submit immediately. Okay. Thank you.